Hello everyone, welcome to my channel. This is G. Varun, pursuing my education in Sri Venkateswara College of Engineering, Bangalore. Now, today in this video, we will discuss about the structural engineering. Structural engineering is the basic branch of civil engineering. Before, what is structural engineering? Structural engineering deals with wide variety of structural systems like building, bridges, dams, transportation systems, water and sewage systems, distribution facilities, power generation stations, storage tanks, and many other facilities that must have adequate strength to safely many loads that acts on it during its lifetime. Structural engineering plays a vital role in planning designing the building, the structure. Structural analysis and design are the main components of structural engineering. Structural engineering takes a responsibility about the safety and serviceability of the structure for the lifetime. Structural engineering should accept the natural calamities like wind, earthquake, landslides, etc., and provide remedial measures. Advert of computer has revolutionized the planning, analysis, design, and drawing in structural engineering using software like AutoCAD, Snap, Pro, etc. Following are the scopes of structural engineering. Analysis the design of dams, bridge, stadiums, auditorium, multi-story buildings. Analysis and design of dams, bridges, stadiums, auditoriums, multi-storage buildings. Analysis and design of power generation stations. Analysis and design of steel industrial structures. Repair, rehabitable, and maintenance of structure. Design of nuclear power plants. Design of structural reinforcements for different types of structural components. Structural engineering is a branch of civil engineering that is concerned with the structural design of man-made structures, often described as designing in bones and muscles of the structure. These engineers need to understand the rigidity, stability, and strength of both buildings and non-building structures. This includes factors such as loading and susceptible to earthquakes. Structural engineers work with architecture, building services, engineering, and other professional and may be charged with supervising construction projects. In addition, structural engineers can also be involved in the design of other assets where structural integrity impacts function and safety, such as machinery, medical equipment, and vehicles. Using mathematics, physics, material science, and empirical knowledge, these engineers need to understand the structural performance of different materials and geometries in order to apply structural engineering designs concept to build structural systems. This work need to be completed within budgetary requirements while making sure and structural elements are suitable for purpose. What is structural engineering's history? One of the oldest type of engineering is structural engineering, dating back thousands of years. Structural engineering became a distinct profession from architecture during the Industrial Revolution of the late 19th century. Before this, architecture and structural engineers were put together under the title of master builders. The name of many of these earliest pioneers of structural engineers have been lost to history, but Imhotep, who oversaw the construction of Forak Diozer step pyramid in Egypt in 2700 BC, is the first structural engineering to be known by the name. Throughout ancient and medieval history, most of the work for construction was done by stonemasons, carpenters, and other artisans under the direction of the master builder. With the knowledge of how structures stood up to loads and the elements being based on the experience and institute that was often held by guilds and not widely shared. Over the centuries, Many scientists and mathematicians made contributions to the what would be the foundation of structural engineering, including names such as Leonardo da Vinci, Galileo Galilei, Robert Hooke, Isaac Newton, Leonard Euler, Daniel Bernard, Claude Lewis, Navier, and Mori. Other prominent structural engineers include those named became synonyms with well-known structures such as Gustin Eiffel, who famously oversaw the construction of the Eiffel Tower and the Statue of Liberty. Many of today's famous structures owe their existence to business or government agencies such as Large Hadron Collider or the James Webb Space Telescope. Types of structural engineering jobs. Different structural engineering jobs can be broken down by what sort of structure is being created. Building engineering. This large area of structural engineering is closely related to architecture and involves the engineering related to the design and function of all types of buildings. While architecture is more concerned with aesthetic, structural engineering is more focused on the functional requirements and safety of the buildings, ensuring that they can withstand movements or other forces that could cause failure. This area of structural engineering includes a number of if specialties including earthquakes engineering, facades engineering, fire engineering, roof engineering, tower engineering, and wind engineering. Second, earthquake engineering. This specialism of building engineering is worth considering of its own, concerned with understanding the interaction between structure and the shaking caused by the earthquake. This type of engineering focuses on factors such as base isolation, which allows the structure base to move freely with the ground. Third, civil engineering structures. These structures include bridges, dams, earthquakes, foundation, offshore structures, pipelines, power stations, railway retainable walls and structures, reservoirs, roads, tunnels, waterways, and more. Safety is of paramount importance here, and many of these designs need to be signed off by a chartered engineer. These type of structures often need to cope with extreme variations in temperature, loading pressure or more, as well as being constructed in corrosive environments such as seas, undergrounds, or at industrial facilities. Fourth, mechanical structures. Mechanical structures are those that are able to move as opposed to be static. These structures have to be able to withstand fatigue and variations in how the load impacts the structure during motion. These forces can vary greatly and at the significant rate. So structural engineerings need to ensure that they can be withstood during the structure entire lifetime. Mechanical structures include items such as boilers and pressure vessels, carriages and cokeworks, cranes, escalators, lift, marine vessels, and many more. Fifth, aeroscope structures. Aeroscope structures include everything from aeroplanes to spacecraft, missiles, and launch vehicles. These structures need to be able to withstand different variations of temperatures, pressures, and loading while often being lightweight and stiff. Aircraft structures, for example, are frequently made using thin plates that are supported by stiffeners, bulkheads, and frames that are held different with wells, rivets, screws, and bolts. Sixth, nanoscale structures. Nanoscale structures are those that are a size between molecules and microscopic. These can be nanotextured, nanotubes, or spherical. Nanoscale particles are also known as ultrafine particles. Although UFPs can be large than nanoscales and reach up to micrometer in size. Seventh one, medical equipment structures. Structural engineering is also used in design of medical equipment. This includes for diagnostic equipment, surgical equipment, and monitoring equipment. Again, safety is of vital importance as is the structural integrity of these items. Next, we will discuss about the structural elements which are used in structural engineering. Although there are many different applications when taken back to the most basic level, there are only a small number of different structural elements. They are arcs, beams, catenaries, columns, plates, shells, and many more. Where do structural engineering work? Most structural engineering works in an office environment to working on structural engineering designs for construction or engineering consultancies. Although other will work on site to oversee the actual construction. Structural engineers may be called to work on new design or to help plan a change or use of an existing structure. This could include adding floors or an area of expansion to a building, ensuring that the structure is still safe and able to meet the requirements of the use. Structural engineerings are also called upon if there is a damage to an existing structure, whether from corrosion, fire, flooding, or even just general wear and tear. This work will require the engineering to visit the site and visually assess the structural integrity of load bearing the elements and suggest repairs to return the structure to a usable state. Let's certification. Certification is an important part of career in engineering as it allows you to prove that your knowledge and experience to the employers. Depending on where you work, you may require certification as structural engineer. You can gain support with your career progression, though membership of the professional institute such as structure, which can also help open the door to different job opportunities. What are the knowledge and skills needed to become a structural engineer? Structural engineering works to combat factors such as wind, snow, rain, and the effect of the gravity on a range of different structures. Whether building bridges or homes, the structure need to be able to cope with the condition where they are built. This may be the weight of snow on the roof of a home in Canada or the potential for earthquake in California. Working with different materials, engineers will analyze data and reports, consult maps and plans, estimate cost based on the materials, equipment, and labor determines stress factors on the structure. Monitor construction progress at a site and even access environmental condition, traffic pattern, the flow of people, and other categorical factors to identify potential problems. All of this work requires a particular skill set, including an in depth knowledge of physics and mathematics. In addition, these are engineers need to understand the properties of different materials including density, hardness, bulk modulus, and their bending and the textile strength. This allows engineering to calculate how a material will perform under different conditions, loads, and stress, often over an extended period of time. Much of this work is made easier through the use of computer systems, including computer aided design systems that allow for faster designing and modification as well as virtual 3D visualization of completed parts, assemblies, and structures. Then we will finally conclude that structural engineering is a special field within civil engineering that focuses on the framework of structure, both large and small, working with everything for the largest building and bridges to nanoscale structures. Structural engineering often specializes in different materials or structures. Structural engineering is the most important for societies around the world to ensure that the structure around us are safe and fit for purpose. This is a big responsibility for structural engineering who design structures to withstand the stress and environmental impacts they are subjected to daily. Do like, share, and subscribe to my channel. Thank you, everyone.